So write down the topic for today. This will be the third property, electron gain enthalpy. Electron gain enthalpy. So what exactly is electron gain enthalpy? But before we discuss what is electron gain enthalpy, what is the symbol for electron gain enthalpy? Just as ionization energy was denoted as IE, the same way electron gain enthalpy is denoted as delta EGH. Okay, electron gain enthalpy is denoted as delta EGH. So, as the name implies, you are gaining electron, and during the gain of electron, how much energy is taking place, energy change is taking place, that is referred to as electron gain enthalpy. Let me repeat again, what is exactly the electron gain enthalpy? The meaning of electron gain enthalpy is, it is the energy of, write down the definition, the amount of energy change taking place when an electron is added up to the outermost shell of an isolated gaseous atom. Okay, so try to understand the definition. Electron gain enthalpy is nothing but it is the energy change taking place when an electron is added up.
Sir, you are not audible.
Shell of an isolated gaseous atom. So again, why are we supposed to take the atom in the isolated gaseous state? So that there is no influence by the neighborhood atoms, and that is why.
Sir, the voice is low.
Sir, you are not audible.
I'm not audible.
No, sir, your voice is low.
Okay, just a minute. Okay, just a minute. Is it okay? Am I audible now?
Sir,
Am I audible now?
Yes, sir.
Yes, sir.
Yes, sir.
So what I was saying was, it is the amount of energy change taking place when, put a when in between, when an electron is added up to the outermost shell of an isolated gaseous atom. So as I said that isolated gaseous atom is such a system where the atoms are generally far away from each other, and one atom will not influence the performance of the other atom. And that is why we say that the atom, whether you are taking the electron out of it or you are adding an electron to it, it has to be in the isolated gaseous state. And that is why we are using the term isolated gaseous atom. Now let us try to understand the phenomenon, what is happening. Suppose you have an atom in isolated gaseous state denoted by X, and to this X you have added up an electron. We know that when an atom adds up an electron, it will be converted to an anion or not? Yes. When you are
Yes, sir.
adding up an electron to an isolated gaseous atom, will it be not converted to an anion?
Yes, sir.
Okay. Now, when it is converted to an anion, during this process, what is the amount of energy change taking place? That is referred to as electron gain enthalpy. So, electron gain enthalpy, let me tell you, is not energy. Okay, it is not energy. What it is energy change. So there is a difference between energy and energy change. When we are using the term energy, it is a, you can say, it's a single word. But when we are talking about energy change, it is the difference of energy that is taking place. So there is a difference between the two. So hence we say that when we are adding an electron to an isolated gaseous atom, whatever energy change is taking place, that is referred to as electron gain enthalpy. But when we discussed about ionization enthalpy, that was not an energy change. That was the energy that was required to remove the electron from isolated gaseous atom. Now the question arises, energy can never be negative, but energy change can be negative or positive. And depending upon the delta EGH can be positive value or negative value also. Because change can be negative, but individual energy can never be negative. So therefore, ionization enthalpy, you are never getting negative value, but electron gain enthalpy, you will get sometimes negative values also, sometimes positive values also. Why is it so? And when will it be negative and when will it be positive? That we need to understand. See, if you are putting an electron to the isolated gaseous atom, so it is obvious that only if the atom is interested in taking the electron, it will take the electron. Now, some atoms are very much eager to take the electron as they are short of only one electron in their outermost shell, which we call as the halogens. Okay? Fluorine, chlorine, bromine, iodine, all these atoms are just short of one single electron to complete the octet. And that is why for such kind of atoms, when they accept the electron, they wholeheartedly accept the electron. And during this process, energy is released. It is just like saying that if you want something of your need, so you have to pay for it. Okay. And you are eagerly paying for it if you are actually in want of it. But there are some atoms who do not require this electron. And if you do not require the electron, still you are wanting that electron should be added up, then what will happen? So you will have to do the process forcibly. Isn't it? Are you getting my point?
Yes, sir.
Yes, sir.
So some atoms are in need of electron, some atoms are not. So those who are in need of electron, they release great amount of energy after accepting the electron. And those who are not in need, obviously what will they do? They themselves are not interested. But if you apply great amount of energy from outside, then they are bound to take the electron. That means depending upon the delta EGH value, you can easily make out whether the atom is interested in taking the electron or not. So what kind of atoms will show the negative value? Always remember, whenever energy is released during the process, the processes are called exothermic in nature. And whenever energy is absorbed during the process, it is referred to as endothermic process. So those atoms who are in great need of electron, they will easily take away the electron, and in return, they will release greater amount of energy. And more the amount of energy that is released, we can say that more easily the electron is acceptable to the atom. But if the atom is not in any mood to accept the electron, then obviously it will not release energy. There is no question. If you are into a shop and you don't want a thing, it is in front of you, obviously you will not show any interest to buy that thing. And you will be bound to buy only if the shopkeeper persists. If the shopkeeper forces you, keeps on saying that please buy it, then only you are going to buy it. Otherwise, you don't have any interest. But if the commodity is of high interest to you, then the shopkeeper should not say anything, and you yourself will buy the thing by paying whatever its cost is. So money comes out easily out of your pocket if you easily accept the thing. But if you do not easily accept the thing, money will not come out of your pocket so easily. Rather, somebody has to force you. So that is what is the meaning. So if delta EGH is negative, energy is released during the process. And by looking at the value of the delta EGH, we can make out whether the atom is easily accepting the electron or not. And if delta EGH is very low negative or positive, then we can say that atom does not show interest or very less interest in accepting the electron. Are you getting my point?
Yes, sir.
So which kind of atoms do you think will show negative or high negative delta EGH value? Which kind of atom do you think releases great amount of energy after accepting the electron? Or it can pay a huge amount of energy to accept that electron. Which type of atoms are they?
Halogen.
Halogens. Because they are badly in need of electron, isn't it?
Yes,
Yes, sir.
sir.
Yes, sir.
An atom is badly in need of one electron, then they are going to release a high amount of energy to get that electron. But if the atom is not so interested, like the noble gases will not show any interest towards the electron because their shells are already completely filled up. And if they do not show any interest towards the electron, so obviously, even if you want that the electron should be accepted by it, the noble gas will say that I'm not going to accept the electron from my own side. You have to supply a huge amount of energy to get the electron in. See, I give you a very simple example so that you can understand the things. Suppose you have a school and there is admission going on for, say, class 11, because you people belong to class 11. Now, if the school has got certain number of students to be filled up and they are short of say 5 to 6 electrons, and then their admission procedure will be completed. To get that 5 and 6 electrons, I mean 6 students, so obviously they will hurry up because somehow if these 5 to 6 seats are filled up, then their whole procedure will be over and they can start the class. So the procedure becomes very fast. But after all the seats are filled up and still the students come to get admission, so obviously the students, the school authorities will not show that type of interest as they used to show when the seats were vacant, isn't it?
Yes, sir.
Okay. Now, suppose a particular section can accommodate maximum of 30 students, and all the 30 students admission have been taken already, and thereafter one more student comes. So obviously the principal will say, as we cannot accommodate more than 30 students, so the answer will be no. And even if the parent or guardian insists that no, please take our student, then what kind of answer will be provided by the principal instead of saying no? So he will simply say that if I admit your student, I'll have to construct a new room. I have to engage more teachers for that particular single student of yours, and which is not possible because it will be obviously a very expensive matter to carry out, and that is why it is not possible to take your ward. So exactly in the similar way, when you are giving an electron to a noble gas, the noble gas does not have the space to accommodate extra electron. And that is why the noble gas will put in condition that if one more shell can be constructed where the electron can be added up, for which obviously a huge amount of energy is required, is to be supplied, then only the process of acceptance of electron will be possible. So in other words, noble gas is saying no to the electron by putting a condition that if you want to get in, then a huge amount of energy has to be supplied from outside. But exactly the reverse happens when you are supplying an electron to a halogen. That electron does not require much of pleading to get added up because the halogen itself is very much interested in accepting the electron. And therefore, to get that electron, it will release a huge amount of energy. And that is why we say that atoms which accept the electrons easily release energy after accepting the electron, thereby making delta EGH negative. Is it clear or not? Is it understood, my dear students?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
So which kind of atoms will release highest amount of energy after accepting the electron?
Halogens.
Halogen. Those who are short of only one electron, because that electron will be of great importance to the atoms. But the same delta EGH will be relatively low negative if the atom is in lesser need, or positive if the atom does not want any electron to be added up. So looking at the value of delta EGH, you can easily make out whether or not the atom is interested in taking the electron. Clear?
Yes, sir.
Okay. Have you written down up to this much? Can I proceed further?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, fine. What is the difference between ionization energy and electron gain enthalpy? Ionization energy was the energy required, and electron gain enthalpy is the energy change taking place. Ionization energy was measured to remove the electron, and electron gain enthalpy is measured when an electron is added up. But in both cases, the similarity is whether you are removing the electron or whether you are adding up the electron, both the processes are being done to isolated gaseous atom only. Now, let us talk about the factors affecting delta EGH. So what are those factors that affect the electron gain enthalpy process? So just as we discussed certain factors affecting the ionization enthalpy in the last class, so same way we are going to discuss the factors that affect the electron gain enthalpy. To start away with, we first talk about atomic size. See, if you consider two atoms with different size and both of them are given an electron to be accepted, this electron wants to get in here and this electron wants to get in here. So where do you think out of the two atoms you will have greater force of attraction, because of which the electron can be easily accommodated if the atom wants so?
In the first case.
The
First
small
one.
one.
The smaller one. Smaller one.
Why? Because the distance between the nucleus and the electron is lesser in the first case, and that is why there will be greater force of attraction. And remember, greater the force of attraction, more will be the amount of energy released. Is it understood?
Yes, sir. Yes, sir.
Any doubt? Greater the force of attraction, more will be the amount of energy released. Because always remember that there are two types of forces. One is force of repulsion and one is force of attraction. When there is force of attraction, it leads to stability of the system. And when it leads to stability of the system, energy of the system decreases. And when energy of the system decreases, it means energy is released during the process. So this simple thing you'll have to remember. Again, I'm repeating. You have two types of forces, forces of attraction that leads to decrease in the energy of the system. And when the energy of the system decreases, energy will be released. Because outside, when you are releasing greater amount of energy, so inside you will be left with lesser amount of energy. So therefore, greater the force of attraction, more will be energy released. So out of these two, where more amount of energy will be released when electrons are added up? First
Smaller
one
one.
of the smaller. Therefore, we can say that under atomic size, smaller the size of the atom, greater is the force of attraction between the nucleus and the electron to be added. Resulting in greater negative delta EDH. Resulting in greater negative delta EDH. So smaller atoms have relatively more tendency of accepting the electron, and in return they will release larger amount of energy, and therefore delta EGH will be. Point number two is of course nuclear charge, which is also not very difficult to understand. Suppose we have two atoms of more or less similar size. One has 10 protons in it, let us say. One has 11 protons in it. So my question to you is, who is going to release greater amount of energy after accepting the electron?
11 proton.
11 protons. Why 11 protons? Obviously, because greater the number of protons, more will be the force of attraction, isn't it?
Yes, sir.
Yes, sir.
More the force of attraction, so greater will be the amount of energy released, and therefore the atoms with greater nuclear charge, higher number of protons at the center, will release greater amount of energy, and they will have relatively more negative delta EGH. more the number of protons at the center, more is the nuclear charge. And greater will be the force of attraction between the nucleus and the electron to be added, resulting in more negative delta EGH. So all those atoms which have higher number of protons at the center will attract the electron very easily. And when they attract electron very easily, so in return, they will release a greater amount of energy, and more the amount of energy they are releasing. So we say that more negative is the electron gain enthalpy. Clear or not?
Yes, sir.
Yes, sir.
Sir,
Yes.
sir, why when, sir, why is it when the energy is more, the value is negative more?
Okay. When you are spending a huge amount of money for buying the things, you will be left with large amount of money or less amount of money.
The less.
Obviously, when a particular atom wants to accept the electron, so in order to accept the electron, it needs to release large amount of energy, isn't it? So in return, it will be left with less amount of energy or large amount of energy.
The less.
So previously it had more energy. Now it is left with lesser amount of energy after accepting the electron. So when something is decreasing inside you, will it be negative or will it be positive?
The negative.
Not clear.
Yes, sir, clear.
So whenever you are spending high amount of energy, you will be left with less amount of energy. So anything that is being spent results in lesser value within you. And therefore, when we compare the value and we find out the difference between the final value minus initial value, it will be a negative value or not?
Yes, sir.
You had rupees 500 in your pocket and you have spent rupees 300. So obviously you are left with rupees 200. Now, what is the difference of money that you had previously and you are possessing now? So final minus initial, when we calculate the value, will it not be negative?
Yes, sir.
Isn't it? So whenever you spend, you are left with lesser value. And the difference when taken will give you a negative value. Is it clear now?
Okay, sir.
So exactly in the similar way, as energy is getting spent when you are accepting the electron, so obviously you will be left with less amount of energy. And when you are left with less amount of energy, so the difference of energy, final energy minus initial energy will be a negative value. Yeah.
Yes, sir.
Point number 3, which affects the process of accepting the electron, that has been already discussed. Stable configuration. So are the stable configurations interested in taking away the electron or not?
No.
If the configuration is already stable, after accepting one electron, will it not become less stable?
Yes, sir.
Yes, sir.
In the previous class also, we had discussed that when a stable system was asked to give away their electron, they were not very eager, and exceptionally high amount of energy was required to remove the electron from such configurations. So neither they are interested in giving away the electron, nor they are interested in accepting the electron. And that is the characteristic of stable configuration, because they are already stable. They have a symmetrical configuration. And by adding up the electron or by removal of electron in both cases, you are going to disturb the symmetry, which the atom won't want. And that is why if an electron goes near the stable configuration will put a condition that I'm not going to spend energy by accepting you. Rather, energy has to be supplied from outside if you want to be a part of mine. And therefore, what will be the delta EGH value for stable configurations? Will it be negative or will it be positive? Are you spending energy in accepting the electron, or are you supplying energy to accept the electron in stable configurations? What do you think? Yes, tell me.
Sir, not spending.
Not spending. That means if you want to make the process of accepting the electron possible in stable configuration, you have to do it forcibly or not?
Yes.
See, you just ask yourself, if you are interested in any subject, nobody needs to force you to study that subject. You study on your own. But suppose you don't like any subject and you are not studying at all, because it completely depends upon how much is the interest towards a particular subject. So you don't study that subject until and unless the exams come nearby, isn't it?
Yes, sir.
Okay. So you are bound to study under forcible conditions, because you know that before the exams, even if you don't study, you will be in problem. So that study is not study of interest. That study is study under compulsion. Are you getting my point?
Yes, sir.
Exactly in the similar way, the noble gases do not show, or not only noble gases, those who have half-filled symmetry also, they do not show any kind of interest towards the electron to be added up. But still, if you want to make it happen, then it has to be forcibly done. And for that, energy has to be supplied from outside rather than energy getting released from the system. Clear?
Yes, sir.
So in case of stable configurations, energy needs to be supplied from outside so as to make the acceptance of electrons to such atoms.
Sir, the delta EGH value will be positive.
It will be a positive value because you are supplying, the system is gaining energy because you are supplying it from outside. System is not losing. Yeah.
Yes, sir.
Hence delta EGH for such atoms will be positive. So if an atom is interested, it wholeheartedly accepts the electron, and in return it will release energy, and the system's energy will decrease, and delta EGH is negative. But if the atom is not interested in taking the electron, then forcibly it has to be done by supplying energy from outside. And in that case, the system will gain energy. Now, gaining energy leads to stability or instability?
Sir, stability.
No. If a system has
Instability.
higher amount of energy, it is less stable. Energy and stability are inversely proportional to each other, remember. Okay?
Yes, sir.
If a system has lesser energy, then it is said to be stable. See, I just give you another relevant example. If you come across two different persons, one person is highly active. The whole day, he cannot sit, he keeps on talking, and he is restless. And the other person is very calm and quiet. So whom you will call more stable personality? The one who sits calm and quiet, or the one who keeps on jumping?
Calm and cool.
So obviously the calm and quiet has relatively lesser energy or not?
Yes, sir.
Yes, sir.
So
Yes,
lesser
sir.
systems are more stable systems. Remember that. And high energy systems are unstable systems. Clear?
Yes, sir.
So when you are supplying energy to the noble gases so that they can accept the electron, are you making the system more stable or less stable by supplying energy from outside?
Less stable.
Less stable. That means the noble gases, after accepting electron, become less stable as energy is supplied from outside. Understood?
Yes, sir.
Yes, sir.
But halogens, after accepting the electron, are more stable because during this acceptance, they released energy and they are left with lesser amount of energy. Is it clear now?
Yes, sir.
Yes, sir.
So after accepting electron, what is your final condition? Whether it is making you more stable or whether it is making you less stable, that is decided by the delta EGH. If delta EGH is negative, that means you are becoming more stable after accepting electron, and that is quite acceptable. But if delta EGH is positive, that means the system becomes unstable after accepting the electron, and that is why they are less stable, isn't it? After accepting the electron, if suddenly your energy increases, that means you are not stable, and nobody wants to be unstable, and therefore noble gases will show least interest in accepting the electron. Here, any doubt? Please clear it out. Yes, Shubhayu, doubt?
Yes, sir.
Is there any doubt? Please tell me.
No, sir.
Girls, do you have any doubt? Or is it clear? We can move ahead. Adrika?
Sir, clear.
It's clear. Okay. Suppose there are two atoms, A and B. I am giving electrons to both of them so that they turn up to become A minus and B minus. The delta EGH for the first process is negative and the delta EGH for the second process is positive. If I am asked, out of A minus and B minus, who is more stable? What do you think will be your answer?
A minus.
Minus.
A minus will be more stable. It means that A is in position of accepting electron. B B is not in position of accepting electron, because if it accepts the electron, it will lead to a species with high energy and less stability, and therefore it will not accept electron. Clear?
Yes.
But on the other hand, if the same kind of electron is given to it, and after accepting an electron, it is releasing energy, so obviously the system will be left with less amount of energy. And if the system is left with lesser amount of energy, the system is more stable, isn't it?
Yes, sir.
And that is why, by looking at the delta EGH value, one can make out that how comfortable is the atom after accepting the electron. Is it understood now?
Yes, sir.
Yes, sir.
The first type of atom represents which family? First type of atoms represent which family?
So halogens.
Halogens. Very good. And second type?
Noble gas.
Noble gas. So the moment you come across delta EGH to be positive, that means we are talking about noble gases. And if it is negative, it may be group 17, it may be group 16, it may be group 15, because all need electrons to fill up. But more the negative value, it means that it has got higher tendency of accepting electron. And we know that out of all the different groups, halogens have the highest tendency of accepting electron. Clear now?
Yes, sir.
Yes, sir.
So after discussion of electron gain enthalpy and the factors that affect the electron gain enthalpy, we now move on to next very important question. Write down the question. Explain why successive electron gain enthalpies is always positive. Explain why successive electron gain enthalpies are always positive. See, in order to understand it, let us say we have an atom X and it accepts electron so that it becomes X minus gas. Delta EGH for the first time can be either negative or positive. It can have any of the two values. If it is a non-metal short of one electron, obviously it will be negative. And if it is a stable gas, it will be positive. But if you want to provide one more electron to any one of them, the delta EGH2 will always be positive. And there is no exception to this rule. So why do you think that even if the atom was interested in accepting the electron from in the first step, but from second step onwards, it no longer shows interest to that electron, which can be understood by looking at the delta EGH2, delta EGH3, etc., etc. So why do you think that after accepting one electron, thereafter it is not showing that much interest towards the second electron?
Sir, because it becomes stable. Sir, in the first case, the halogens
Because
also.
it become more stable.
No, suppose we are talking about oxygen atom. Oxygen atom requires 2 electrons, isn't it?
Yes, sir.
Yes, sir.
Yes, sir.
If oxygen gains 1 electron, it becomes O minus. So in the second step, it was supposed to gain the electron with more force of attraction or not?
Yes,
Yes,
sir.
sir.
But oxygen, O
Sir,
minus
proton electron ratio, the energy decreases.
is the reason. For the first time, when you are adding up the electron, you are adding up an electron to an atom, isn't it?
Yes, sir.
But after it has gained an electron, it develops what kind of charge on it?
Negative.
Negative. Now, what is the charge on the anion as well as electron? Is it not same?
Yes, sir.
So if both are negatively charged in nature, will they attract each other or will they repel each other?
Sir, repel.
Sir, repel.
Now, if they repel each other and you still want to come them closer, energy has to be supplied from outside or not?
Yes, sir.
Yes, sir.
And because energy has to be supplied from outside to bring them closer as they repel each other, so successive electron gain enthalpies are positive. Understood or not?
Yes, sir.
So no matter whether, just no matter whether the atom was showing interest to the electron in the first step or not, but second step onwards, it will not show interest, or its interest is going to decrease because of the fact that negative repulsion will occur. Clear?
Yes, sir.
Anyone having any doubts? Please tell me in understanding this. Why successive electron gain enthalpies are always positive? I can explain it again. Everyone has understood. Fahim, is it clear?
Sir, can you explain again?
When you are adding up an electron, you are adding up the electron to a neutral species or not?
Yes, sir.
Is an atom. So when you are adding up an electron, you are adding up an electron to the atom, and depending upon the nature of the atom, if it is short of one electron, so it will accept the electron very easily. But after accepting a single electron, it develops a negative charge. It becomes an anion. And in the second step, if you want, the atom should further accept the electron. Will it be easily accepting the electron, or will there be any difficulty now?
So there will be difficulty.
Why do you think there will be difficulty? What is the reason? Why do you think there will be difficulty now?
Sir, due to repulsion.
Due to repulsion. Because from the second step onwards, you are adding up an electron to a neutral atom or an anion.
Anion.
So anions are also negatively charged and electrons are also negatively charged. So they have like charges or not?
Yes.
Now they don't want each other. And if they don't want each other, they hate each other, still you want to make the anion to accept the electron. So you have to supply energy from outside, isn't it?
Yes, yes, sir.
It's like saying that if you have two magnets and both of them have same poles, they repel each other. And if you still want to bring them closer, you have to apply energy or not, or the magnet will attract each other on their own.
Sir, apply energy.
Has to be supplied from outside, isn't it? So both of them are nothing but magnets of same poles. You want to bring them closer, but they are repelling each other. So still, if you want to bring them closer, you have to supply energy from outside. And whenever energy is supplied, delta EGH will be positive, isn't it?
Yes, sir.
Only when energy is released, delta EGH is negative. But Whenever there is repulsion between the two species and still you want to bring them closer, energy has to be supplied, making the delta EGH positive. Clear?
Yes, sir. Sir, after completing the octet also, will it have the positive energy value?
See, after it completes the octet, it is already positive. It does not require any more electron. Isn't it?
Sir, no, if the same situation is carried on.
Yeah. Because you see that as you are adding up electron, the atom is overloaded with electrons. Protons are remaining same at the center. And you are overloading the atom with excess of electron. So obviously, if you are overloading an atom with more number of electrons, so it will be very difficult to accommodate more and more electrons, isn't it?
Okay, sir.
You are in a bus, you are traveling by a bus, and you are inside the bus, and you just see that the conductor is pulling more and more crowd inside. So will you resist it, or you will be very happy about it?
Sir, resist it.
So already the atom is overloaded with excess of electron. So it is not happy in accepting more electrons. So there will be repulsion or not? Isn't it? There will be repulsion. And still, if you want to bring this atom, this electron closer, you have to supply energy from outside. Understood? Is it clear why successive electron gain enthalpies are always positive?
Yes, sir.
Oh. So write down. When an atom accepts an electron, delta EGH may be negative or positive depending upon the nature of the atom. If it is halogen, it is negative. If it is noble gas, it will be positive. However, after an electron is added up, the atom turns into an anion. So it develops a negative charge. An atom turns into an anion. Both anion and electron being negatively charged repel each other and hence energy needs to be supplied from outside to accommodate the second electron onwards. See whether the answer is clear to all of you or not.
Yes, sir.
So supplying the second electron, third electron, fourth electron, and so on will be a difficult task because the system will not show any kind of interest in accommodating those electrons. Why? Because the electrons which are already present will show some kind of force of repulsion, even if the system is yet to achieve the stable configuration. I hope the point is clear.
Yes, sir.
Now, does that mean oxygen will never accept 2 electrons? What do you think? But we have been studying in chemistry that oxygen is short of 2 electrons. And after accepting the 2 electrons, oxygen will become oxide ion and will become largely stable. But at the same time, I'm saying that oxygen comfortably takes the electron for the first time. But when for the second time electron is to be supplied to the O minus, there is repulsive forces. That means, will the oxygen not form oxide ion? What do you think? Have you got my question? Are you understanding my question?
Sir, external energy will be supplied.
Yes. Oxygen will be converted to O2 minus, even though there is difficulty in the second step, provided this minimum amount of energy is supplied from external factor. Because see, oxygen is eager to accept the 2 electron. But the system developed is such that there is repulsion. If you can somehow overcome this force of repulsion by supplying energy from outside, then oxide ion will be produced. So oxide ion is a very common type of ion, which means it is formed, and it is possible only when the external source is capable of supplying this much amount of energy, so that the electron and the O minus ion, whatever repulsion they are having, that can be easily overcome. Understood?
Yes, sir.
It is just like saying that if a particular thing is very costly, is it impossible to buy it? Answer is no.
No,
There
sir.
are some people who are very rich, and even if the thing is costly, as these people have enough amount of money to buy it, so only those class of people can buy it. But for that, they must possess at least that minimum amount of money to buy. It's not possible for everyone. It's a difficult process. But I don't say it is impossible for everyone, because there are people who are in position to buy it. So oxide production is possible in aqueous solutions where the energy is provided by the water molecules. Understood?
Yes, sir.
Yes, sir.
So thus we say that electron gain enthalpy is actually a property that helps us to understand the tendency of an atom to gain electron. Just as ionization enthalpy was the property last class, which was helping us to understand that how easy it is to remove the electron from an atom, and today we are just doing the reverse. So what is the variation, what is the trend of electron gain enthalpy in the periodic table? Because ultimately we are interested in that topic only. So trend of delta EGH in periodic table. How the electron gain enthalpy property changes down the group and along a period. To start away with, we'll first talk about what happens as we go down the group. So as atomic size is one of the major factors influencing the delta EGH process. So obviously we know that as we are moving down the group, atomic size is gradually increasing. And if you are to put an electron, we have already learned that because the atomic size gradually increases, the distance between the nucleus and the electron to be added keeps on increasing, isn't it?
Yes, sir.
So what will be the influence on the delta EGH value? Is it not becoming less and less negative?
Yes.
Here, delta EGH more negative means what? More force of attraction. And delta EGH becoming less negative means what? Lesser force of attraction, isn't it?
Yes, sir.
So as we move down the group, due to increase in atomic size, and lesser force of attraction, between the nucleus and the electron to be added, delta EGH becomes less negative. Because here, more negative means greater force of attraction. So as we are moving down the group, delta EGH becomes less and less negative. Yeah.
Yes, sir.
I hope the point is clear to everyone.
Yes, sir.
Coming to along a period. What is happening as we go along a period to the atomic size?
So it decreases.
So if you go by the atomic size factor, except for few exceptions in between, where there is half-filled stability, as there is a gradual decrease in the atomic size, don't you think delta EGH becomes more and more negative?
Yes, sir.
Yes, sir.
And finally, for group 18, it is positive, isn't it?
Yes, sir.
So which group do you think will show highest negative?
17.
Group 7.
70.
Because as we are moving from left to right hand side of a periodic table, due to decrease in the atomic size, the force of attraction between the nucleus and the electron to be added up keeps on increasing. Now, if it keeps on increasing, the delta EGH should become more and more negative. And accordingly, noble gases should have, was expected to show highest negative delta EGH, but because of their stable configuration, they fall under the exception and they show delta EGH to be positive rather than negative. So accordingly, will not the group 17 elements show the highest negative delta EGH?
Yes, sir.
So as we move from left to right of a periodic table, due to decrease in atomic size, delta EGH becomes more and more negative, except for noble gases, which show positive values. So accordingly, group 17 is the group which shows maximum negative delta Ag. Clear? So any
Yes, sir.
property that is being shown down the group, the trend that is shown down the group, exactly the opposite is shown along a period. There is no property which is found to be similar down the group and along a period. There is no such property. You must have seen that when it was atomic size, it was increasing down the group, but decreasing along a period. Then we talked about ionization energy, which was decreasing down the group, but increasing along a period. Now we are talking about electron gain enthalpy, which is found to become less and less negative down the group, but more and more negative along a period, isn't it?
Yes, sir.
The
Yes,
trend
sir.
is found to be opposite down the group and along a period. Can we move on? Is it done?
Yes, sir. Yes, sir.
But even though we have discussed that down the group in general, delta EGH should become less negative. But here also some exception is found. Let us see. Group 16 and group 17 are considered to be the elements with highest tendency of accepting the electron because they are short of either one electron or two electrons. Group 17 has fluorine, chlorine, bromine, and iodine as the main elements. And here you have oxygen, sulfur, selenium, tellurium. And polonium is also there. Now, just now, whatever I have discussed, according to the delta EGH, who do you think out of these four should have maximum negative delta EGH?
The fluorine.
And who out of these four should have maximum negative delta EGH?
Oxygen.
But experimentally, it has been found out that it is not oxygen or fluorine who are supposed to show the maximum negative delta EGH. Rather, it is the second members, sulfur, it's not Se, S, sulfur in group 16 and chlorine in group 17 who are showing these exceptions. They are found to show maximum negative delta EGH, which means that they are violating the rule. Because even though fluorine has smaller atomic size as compared to chlorine, so it should have shown greater force of attraction towards the electron to be added up. But chlorine in return has been found to show greater electron gain enthalpy. And the trend that has been found out is chlorine greater than fluorine. And thereafter, they are following the normal trend. So there is an exchange in the position of 1 and 2. Fluorine should have been present here, chlorine should have been present here, but chlorine is topping. Same way, sulfur is found to show greater negative electron gain enthalpy, and thereafter they are following the normal trend. So being exception, as I told you in the last class as well, that the exceptional things become very important from examination point of view. Why is it so? So the question that comes out is, even though fluorine is smaller in size as compared to chlorine, but why the energy released after accepting the electron has been found to be more in case of chlorine? And whatever explanation I give you for fluorine, chlorine, the same explanation is meant for oxygen and sulfur as well. So let us try to understand that what happens in case of chlorine and fluorine because of which the opposite trend has been found out. You all are familiar with the fact that fluorine has electronic configuration of 2,7 and chlorine has electronic configuration of 2,8,7, which means that the electrons of fluorine are distributed in only 2 shells, whereas the electrons of chlorine, even though large in number, are distributed in 3 shells. And we know that more the number of shells, more will be the number of subshells as well. Which means that if you want to add up an electron to fluorine, and if you want to add up an electron to chlorine, listen very carefully, it's a very important question. Don't you think that fluorine is already overloaded with electrons according to its size?
Yes, sir.
It has a small size and it is already overloaded with 9 electrons distributed in 2 shells. So if it is already overloaded, the nucleus wants that electron should come in. But the electrons which are already present in these 2 shells will repel the electron to be added up. It is just like saying that country like ours, we are not in position to accommodate more and more migrants from other countries. We would have considered them if our population was less. But in our country, we ourselves are running short of resources, running short of employment. And if people from outside come in, it will be very difficult to accommodate them because the local people here will not get the job. As such, we are not getting it, but there will be more competition and therefore we always repel the outsiders. So exactly in the similar way, when this electron wants to come in, it will not be so easy for this electron to come in as the electrons already present will repel it, isn't it? Yes or no?
Yes, sir.
Now, if still you want this electron to be the part of the atom, of course, it has to be part of the atom because then only it will become stable. So there are two type of tendencies going on. The nucleus wants it to come. The electrons do not want this electron to come in. So there are two types of things which are going on. Nucleus is attracting it. The electrons present outside are repelling it. So ultimate decision is, okay, the electron will be the part of the atom, but for that, it has to spend some amount of energy, isn't it? To overcome the force of repulsion.
Yes, sir.
It is just like saying that if a person wants to board a bus which is already filled up and is overcrowded, then this person who wants to further board the bus needs extra amount of energy, isn't it? To overcome the repulsion created by the crowd already present in the bus.
Yes, sir.
Now, theoretically, suppose we were expecting 100 kilojoules of energy to be released when this electron is added up. Of course, whenever electron is added up, energy will be released because it's a halogen atom. So suppose theoretically we were expecting that this much amount of energy should be released when an electron is added up. But in reality, it has been found out that only 80 kilojoules of energy is released. Where is the rest of the 20? Where is the rest of the 20?
It's lost during the game.
Rest 20 is utilized in overcoming the force of repulsion. Clear or not? Again, I'm explaining. If you have doubt, how much energy was expected to be released when this electron is accepted to the atom? theoretically how much we were expecting? How much energy we were expecting?
100.
What is the reality? How much energy is actually getting released?
80.
It is releasing only 80 kilojoules. So there is a difference of 20 kilojoules or not?
Yes, sir.
Yes, sir.
So you were expecting 100 kilojoules of energy, but in return you are getting 80. That means the rest 20 is utilized in overcoming the force of repulsion between the electrons or not?
Yes, sir.
Yes.
Why? What you expect and what you are actually getting, these 180 are just the hypothetical values. These are not actual values. Just for the sake of explanation, I am using these two values. So though you were expecting 100, but in reality you are getting 80 because the rest 20 has been utilized in overcoming the force of repulsion. Now come to chlorine. In chlorine, no doubt there are 17 electrons. But don't go by the number of electrons. These electrons are very well placed because the number of shells and subshells are also more, isn't it? They are very,
Yes,
they are very well placed in the atom. There is no crowd because even if the population is high, but the region where they are staying is also large or not.
Yes, sir.
When this electron wants to get in, it is not going to experience any force of repulsion. Yeah.
yes, sir.
So suppose due to its size, I was expecting 90 kilojoules of energy. Let us say. In reality, how much energy will be actually released in case of chlorine? If you are expecting 90 kilojoules of energy to be released when this electron gets in, actually how much energy will be released? 90 only, isn't it?
Yes, sir.
Why? Because this electron did not experience any force of repulsion. And if you are experiencing force of repulsion, then only some energy will be deducted to overcome the force of repulsion. But if there is no such force of repulsion, whatever you expected and what you are actually getting will be same. Are you getting my point?
Yes, sir.
So ultimately, which energy released is found to be greater?
Chlorine.
It is chlorine, which is releasing greater amount of energy. And who was expected to release greatest amount of energy? Who was expected?
Chlorine.
Chlorine, due to its smaller size. But in reality, who is releasing greater amount of energy? It is chlorine. Why? Because there is no deduction at all. Is it clear?
Yes, sir.
So write down this question and remember this question. Though chlorine has smaller atomic size than chlorine, however, delta EGH of chlorine is more negative. Explain. Though fluorine has smaller atomic size than chlorine, and if the atomic size is small, they are supposed to release greater amount of energy. But here the reverse has been found to be true. Chlorine has been found to release greater amount of energy. What is the reason? In fluorine, 9 electrons are distributed in 2 shells, making the electron density of fluorine very high. Now, when I say electron density is high, it means it is overcrowded with electrons. As a result, the electron to be added experiences force of repulsion from the electrons present inside the atom. তো যেকেটা ইলেকট্রন অলরেডি অ্যাটমত আছে, ভিড় ভাড়ত আছে, they will repel the electron which is to be added up. To overcome this force of repulsion, some energy is used up, and hence the actual energy released is lesser than the energy expected. See whether you have understood this statement or not.
Yes, sir.
So what you are expecting and what you are actually getting, there is a difference or not?
Yes, sir.
Because a
Yes.
part of the energy is utilized in overcoming the force of repulsion. But in case of chlorine, however, no such repulsion is shown in case of chlorine due to its larger size and lesser electron density. So in case of chlorine, is there any deduction or you get the same value as expected?
Same value as expected.
The actual energy released is same as expected. Ultimately, chlorine is found to show more negative delta AGH as compared to fluorine. Whatever I have discussed, the same holds true for oxygen, sulfur as well. The same case is found in oxygen and sulfur. Who was supposed to release greater amount of energy out of oxygen and sulfur?
Oxygen.
Oxygen.
But what is the reality? Who is releasing greater amount of energy?
Sulfur.
Is it understood?
Yes, sir.
Yes, sir.
So among halogens, the electron gain enthalpy follows the trend fluorine, greater than bromine, greater than iodine. Delta EGH is becoming less negative down the group. But they are not following the common trend. So similarly, sulfur greater than oxygen, greater than selenium, greater than tellurium. So there is a, what should I say, changeover of position between chlorine and fluorine, though we were expecting fluorine, chlorine, bromine, iodine, but it has been found to be chlorine, fluorine, bromine, iodine. And similarly, we were expecting oxygen, sulfur, selenium, tellurium, but what we are getting is sulfur, oxygen, selenium, tellurium. I hope it is clear.
Yes, sir.
So after today's discussion, we have come to the conclusion that those who are highly non-metallic have high negative delta EGH, isn't it?
Yes, sir.
Yes, sir.
Because non-metallic property is measured on the basis of its desire to accept electron. Last class we discussed that lesser the energy required to remove the electron, lesser the ionization energy, more metallic is the property, isn't it?
Yes, sir.
Yes, sir.
So it means that in order to be more metallic, the ionization energy should be low. And in order to be more non-metallic, the electron gain enthalpy should be more negative. So these two important facts must be taken care of, because based on this fact, the whole concept of chemical bonding is lying. So when the two atoms combine, what type of bond they will form completely depends upon the metallic and the non-metallic property. If one is very highly metallic and if the other is very highly non-metallic, then the type of bond they will form is called an ionic bond. But if this difference of metallic and non-metallic property keeps on decreasing, then that bond slowly turns up to be covalent bond. Understood?
Yes, sir.
So whether a given bond is ionic or covalent depends upon the metallic and non-metallic property. Greater the difference in their property, more is the ionic character of the bond. And lesser the difference between the property, more covalent is the bond. Understood?
Okay, sir.
So the whole concept of chemical bonding actually is based upon the periodic classification. And that is why we need to understand each and every point very deeply. Because if you skip out this chapter or some points, then you will face difficulty in the next chapter and next to next chapter as well. Okay. So we have covered
Okay, sir.
the electron gain enthalpy today. So next day we will move on to relatively smaller properties like electronegativity, valency and valence atoms. Thank you. Good night, all of
Thank
you.
you, sir. Good night.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.